This is the malware fingerprinting track for you in the audience, just in case make sure you're in the right place. I have the privilege today of introducing Patrick Thomas. And I say privilege because this is one of the sessions I was going to come to regardless of whether I was proctoring or not. So glad to see you guys could make it. Today's presentation is the white elephant. This is what? BlindElephant. The BlindElephant, excuse me. You want to give me the whole title, or you just want to go ahead? I'll just turn it over to Patrick, and I'll let him introduce it. Sorry.
I totally should have seen that coming when I named something BlindElephant. It's going to be white elephant in everyone's mind, so I'll just get used to that. Okay, as you said, we're talking about how am I doing volume-wise? Okay, cool. Web application fingerprinting. Talk a little bit about web applications, some of the interesting challenges they have for security, some of the ways in which we need to think about web applications differently, and then talk a little bit about the existing fingerprinting approaches that are out there. Talk about some of the problems that we have with that, some of the reasons why that didn't serve some of our needs, and then the static file approach, take you through the details of how that's done, and then once we actually had a tool that does that, we said, all right, let's go out and use this tool. Let's make some observations of the entire net and draw some conclusions about how people are actually doing with web application security. If we have time at the end, we'll do some Q&A, and hopefully in there we'll also be able to actually run this thing on some web apps that you guys are running, see if you're up to date. Well-known web applications, that's what this talk is about. There are lots and lots of custom web applications out there, people doing all sorts of new stuff, in-house, little one-off web apps. We're not talking about those. We're talking about sort of well-known, off-the-shelf, whether open source or commercial web applications that are used in all of these things. People expect web apps to be blogging, to be content management systems, to be maybe e-commerce, all of those things, but web apps are very much tons of other technology. Emails, and say squirrel mail or any of those, PHP MyAdmin, many of these things that used to be sort of large, dedicated enterprise applications or thick client or desktop applications, for all the reasons that we take things to the web, are becoming web apps. So when we talk about web application security, it's not just simple stuff like your company's marketing blog. Real serious infrastructure type stuff is very much managed in web applications right now. The typical slide that everyone needs. These are some of the well-known web applications we support in BlindElephant currently, most of the ones on this list. I'm sure you guys use these things very much on a daily basis. So special challenges. We were talking about how are web apps different than some other stuff. They're remotely accessible by nature. That's the big thing. Any exploit that you have in a web application is, by default, a remote vulnerability. And if it's on your intranet, it's typically available to your full intranet. If it's on the internet, it's available to the entire internet. Lots of attack surface. This is an interesting one. You've got all the direct attacks, the injection attacks, stuff that comes in from the front end. You've also got indirect attacks, cross-site scripting, CSRF, all of those things that you're going to bounce off of a legitimate user. So lots of things going on in web apps, lots of functionality being added, quick development cycles. Also, these things are phenomenally easy to set up. Many of them will say you've got your 5-minute install or your 1-click install, those sort of things that power users say, hey, cool, one less thing I need to worry about. But some of the users who wouldn't necessarily go and install a web app or set up a new application will say, hey, this looks really easy, or my friend told me this was really easy, go and set it up. And they're not necessarily going to go through the channels that they might used to if something was really hard. If you think it's going to be a painful several-hour process, you're going to set it over to IT. If you think you can just spin up a database and a web app in a few minutes, these are the kind of things that fly under the radar. Fast release cycle, we talked about that for all the reasons that we like developing web apps. They have that other side from the administering, from the maintenance, from the security perspective. This one, some people may disagree. I think it's actually true. Exploits are simpler to comprehend and therefore also simpler to create, to propagate, to execute. Here's 2 examples of actual complete working exploits. These are known published ones, a WordPress admin password reset and a Joomla, I think it's a file disclosure, and executable via or exploitable via wget. You don't need IDA Pro, you don't need any of these deeper tools that takes a little bit more domain knowledge to understanding these exploits. So there's a lot going on in web application security, and of course, everything the WAF vendors are saying. I won't reiterate all of that. Whoops. There you go. Web application scanning, lots of cool problems going on in there, lots of hard problems, lots of really interesting research. We're very much not doing that. This is web app fingerprinting. We're saying if it's a known off-the-shelf web application and you've got vendor-published vulnerabilities or community-published vulnerabilities, then it's very much like traditional vulnerability management, where if you're running XPSP2, we know you're vulnerable to all of these different things, and that's actionable. That's something that you care about, whether you are a system administrator or a pen tester or an auditor or something like that, or whether you're building this into tools. So knowing the version is good enough to infer these well-known vulnerabilities. It's definitely not as sexy as WAS, but this works, and I'm going to talk a little bit about why it works. So discovering the app and the version is fingerprinting. Quick theory of fingerprinting. We don't need to dive too deeply into this, but we're looking for some characteristic that identifies an individual. Now, how we define individual depends what we're doing. If we're doing criminology, then it's the actual fingerprint. This thing identifies me differently from this gentleman in the front row who loaned me a power cord. If it's, for example, an operating system or an HTTP server, a lot of the logic on that relies on sending slightly malformed packets, maybe several different aspects of the packet that don't conform, and seeing which errors come back. And often you need to try a whole bunch of different things, and then the intersection of those can give you more information than any one. So OS and HTTP fingerprinting are very well-known standard tools in the toolkit. What we're doing is providing that technology, that tool in your toolkit at the application layer. Some existing approaches, by and large, are regular expressions. Lots of tools out there that do some variant on load the home page, look for some string that we've computed. Works reasonably well, doesn't fit our purpose for a couple of reasons. One of them is there is human effort involved in finding each of those strings and supporting each of those applications. If a new version comes out that provides different strings, say included JavaScript functions or something in the comments or a meta header, any of those kind of things, a human has to go through, take a few examples, look at it, make a judgment call, and write a regex. And it's only a few minutes, say, per version or per new application. But with the explosion of many different web applications times many different versions, in many cases times many different plugins, and then again times versions of those plugins, we need something that will scale very, very well. If there's any human judgment in the loop, we cannot scale with this. So we're looking for something that takes human judgment out of the loop on all of this. Also, decent hardening. If somebody is going in and saying, hey, I don't want to say that I'm powered by WordPress or powered by PHP-BB. I want to take that out. I don't want to say that it's proudly running version 1.5. I'm going to make that go away out of the source code. There are lots of guides for doing that. Many applications are sort of getting on the bandwagon and saying, we're going to go ahead and provide a little checkbox that says strip all identifying information. And for applications that are not doing that, there are people coming in, third parties, and providing plugins that will do that. You can say, install this plugin and make all your identifying information go away. And then finally, though people aren't doing this as much, they're very easy to lie to. If you want to claim to be a completely different version than you actually are, you can just simply put that into the code and go with it. Some fingerprinters like that down here. These are not bad tools. These are very useful tools, but they don't meet some of our needs for those reasons. Slightly more advanced tools, we see a little bit of advancement in usually one area. Securi were the first people to talk about this static file fingerprinting. I saw it on a blog entry of theirs a while ago. They were sort of doing a proof of concept. It was got some good results, but it was fairly manual. It didn't pin things down to a particular specific version, so it was a little bit less actionable. What Web is doing a whole lot more, is gathering an astonishing amount more data, but they end up pulling down so much data that's really not useful for scanning large numbers of machines or not setting off every IDS in the country. All right, so setting out some goals for any fingerprinter, web app fingerprinter in particular. We want it to be very generic. We want to run the same code for every single app that we come across, for every single plugin. We want this to be very data-driven. All the logic is in the data. We want it to be fast. My goal was, you shouldn't have to go get a cup of coffee while this thing's running. Ideally, you shouldn't even have to reach for your coffee. We'll see how that goes. We want it to be low resource usage. You shouldn't abuse the machine on the remote end, and you shouldn't have to have a gargantuan machine on your end. Accurate, low false positives, low false negatives. These are the things that make a tool actually useful. Obviously resistant to that hardening and the banner removal that is slowly starting to happen in web applications that was used by the regexes. And then here, I am just one person. I'm trying to support a lot of web apps, so I need to design a system that would be very, very easy to support new apps. And then if I'm asking people outside to help me with that, I want to make it very, very easy for them to help support a new app that maybe they only have access to. All right. So it's called BlindElephant, and it comes from this old Indian fable. Hasn't anybody heard this Indian fable? A couple of hands? OK. I think this is really cool. It's a parable on the unknowability of truth. A number of blind men or men in a dark room are all touching an elephant and trying to agree amongst themselves what it is. And one of them touches the side of the elephant and says, it's a wall. Another one grabs a leg and says it's a tree, or the trunk and says it's a vine. And they all see sort of this one aspect of the truth, and the sort of cone aspect of it is you can't truly know all of truth. And it's a cool little parable, but it pissed me off because if they would all just say the things that it could possibly be, very quickly they'd come down to it can't be all of those things together, but it can be this elephant. So, it's a tree or an elephant, it's a spear or an elephant, it's a vine or an elephant. You put those things all together, you intersect those possibilities, and we have an elephant. So that is exactly what is going on in static file fingerprinting. Really no more, no less. So if you keep that in mind, the rest of these slides should make perfect sense. And if you go to look at the code, that's really all that we're doing. OK, so how do we do this? Preparing the data. Go get every possible version of an app that you can get your hands on. Whether you go to Subversion and check out all the tags, whether they've got a nice archives page and you just right-click and say download everything here, however you want to get those versions, dump them into a directory, unpack them. I've got some scripts for that. And then what we're going to do is we're going to build two tables. The data files on the left, lots of data going on there, lots of files, gigs and gigs. We're going to compress that down to these two things that we actually use to make the decisions about fingerprinting, which end up being a little under a meg, depending on what you're dealing with. So these are very easy to transport. Those are in Subversion, and you can check those out and get them and play with them and see what kind of data is encoded in there. We use these data tables to answer two questions. The first one for the paths table is, what versions will a path give me information on? If I fetch this particular path, /resources /something.css, what versions is that file present in, and what versions does it differ in? Therefore, if I